Hey guys, John here with Knifemaking Tuesday, week 13. Quick week today. Don't have a lot of time. Turns out Tuesday was my two-year-old birthday, so didn't really get any work on Tuesday. Today's Wednesday. Got a little bit of time. Main thing I want to try today is to at least make my test blades. So I'm going to make at least one test blade for framelock flipper, and put it together with my new titanium handles. So let's get right to it. Alright, so next step is I got my framelock handle here. I've got a detent ball. This is a 2mm detent, which is about 78 thousandths of an inch. And the hole I've drilled is 1/16 inch, which is 62 thousandths of an inch. The difference being about 16 thousandths. The ball of 16 thousandths oversize. I was reading on the forums, and ideally 5 to 7 thou oversize is what you want. Mine's 16 thou, like twice as much as you should, so it's really going to have to stretch that hole to be pressed in. But that's the only size drill bit I had compared to the balls, so it's going to have to do. So the trick is, and I was reading on the forum, a USN forum, I have a 16 thou washer here. Now, eventually the gap between my blade and the handle is going to be about a 15 thou gap. So a 16 thou washer will keep the ball spaced up at about 16 thou, like sticking above the surface, 15, 16 thou. So I'm going to put the washer there as a stopper, I guess, and we'll use my milling machine and see what we can do. So on the machine now, you can see we got the detent ball just kind of sitting there, 16 thou washer, and in here is a 1/4 inch end mill. 1/4 inch end mill backwards, pretty flat on the end. And I'm basically just going to use my machine to push it down, and we'll see if this works. Got contact, and my end mill is slipping up into the chuck. Like I said, the hole's not big enough, really. Oops. There. Lost the ball. Nice and tight. Oh, there it is. Can't believe I found it. What are the chances? Let's try that again. Not really working. Alright, so I've, guess you could say, given up. Got the ball in. You can see it's flattened quite a bit from that procedure. It's a hardened ball. Whatever. Got my 16 thou washer here. Just give me a second. I measured the ball to be sticking up about 32 thou, so twice as thick as what I'm shooting for. Not a big deal. The only difference that will make, I think, is when the blade is partway closed, the handle will be sticking out 16, or the frame lock will be sticking out 16 thou more than it should. If I had the ball sticking out 15 thou, then the frame would be perfectly even when the blade's halfway closed, if that makes sense. So we'll see. It's in there for good now. I mean, I'm pretty sure it's more than halfway in, maybe. Hard to say. 70, 32. It's just over halfway in. So it should be fine. And I got just finished my first dummy blade. So I got this by my thumb is the stop pin section. This here is the closed stop pin section. Here's my detent hole. It's a 1/16 hole. Remember, the ball is 1/16 out bigger than that. See if I can line them up here. If I can find it. There. Ooh. Fits nice. So I'm going to leave that like it is right now. If you'd focus. I might go back and chamfer it, put a 90-degree angle or something on the hole so that the ball progresses into the hole and progresses out, as opposed to just dumps in, stays out. But I'll start with this first because I can always chamfer later. Alright, so I got my 3/16 stop pin. Now this is where it goes. This groove right here is where it goes when the blade is closed, and this is the one where it goes when the blade is open. Stay focused, camera. Now I was really smart this time and actually drilled and reamed these holes first so that they're exactly the right size, as opposed to counting on my end mill to contour in there and get a perfect circle. It doesn't happen. So I reamed them, which is awesome, and now they're perfect match to this pin. The problem is I didn't contour into the hole enough, so as you can see it doesn't slide in there enough. If I slide it in like that, it works fine. So I just need to go in there with a file or whatever and change my code, obviously my design, so that it'll roll into there no problem. Got to file it down just enough so that it slips in there now, no problem. Awesome. Now, as was I think the case with the stop pin in this one, it's too long. It comes too long, the ones that I bought. So I'm gonna, instead of wasting time and shortening this, I'm just gonna steal it out of this one. So, fast forward. Okay. See? Much shorter. Forget what size I ended up being. 2.6, 2.61, something like that. Maybe I'll buy 1/4-inch pins from now on. Okie dokie. Perfect. Perfect. That's too small. A bit longer than 1/4-inch would be the right size. That's okay, it'll work. Alright, moment of truth. Notice I'm using ball bearings again. As always, love these little guys. So a hardened steel washer goes on the titanium side first, because titanium does not make a wonderful bearing surface. It works, but peace of mind, I like putting the hardened washer in there first. Okie dokie. Got my blade. Just make sure I'm putting this in the right way. Yep. Okay. Put my pin in. I guess I would be wise to pre-bend the lock bar. I haven't done that yet. There, put some pressure on it. Okay. Still a little sticky. The stop pin groove, gonna have to file that down some more. It's mostly just on the upper side here. I was smart enough on the bottom side to taper it in. Luckily, doing this doesn't affect the lockup, like the engagement, whatsoever. Try it again. Wait, still a little bit more. That looks like it's on the bottom. Is this getting boring? I hope not. Sorry if it is. Well, we'll see. It's still a tiny bit sticky, but we'll, actually, now I can kind of see if it'll lock up. Maybe. Okay, then we do that, and then we do washolio. Then we do that. Stop pin, and then we do, since notice how the pivot is too long, I still have to shorten it, so we're just going to cheat and use a bunch of washers. Got the same problem in the closed position. It's sort of dink, dink. Oh wait, that actually could be the detent. Durr. Oh, that detent is badass. Alright, so I gotta put a spacer in the back, but... Oh! Ding, 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 we have a winner. What do you win? The world's coolest knife. This is gonna flip insanely fast. Wow. Detent closed, works awesome. It's never going out. I doubt you could even flick it just like that. But the flipper looks okay. Good size. Yeah, it's a good size. And as far as lockup, this is one of the big reasons we're doing this test in the first place. Let's see if maybe you can see this way. It's barely engaging. Hardly anything, if at all. Maybe I can get my flashlight on here. So, yeah, that's why I'm doing this test, to make sure I can get it to engage. Looks like I have to cut it back a little bit deeper. But I don't know. Maybe I'll make another test blade, who knows. These handles with that blade. Flipper frame lock. There. Ha ha ha. It's hard to flip it because they pinch together at the bottom. They're actually holding the blade right here. But if I space them out with my fingers, yeah, it'll be fast. I guarantee it. It'll be easy and fast. It's just got some drag because I didn't make it very well. It's a test, that's all it is. Even at the bearings, the blade isn't totally centered. But that's pretty comfy. Pretty comfy choil right there. How's the jimping? Good. Pretty clean line going from the handles up to the jimping. I like that. Of course, I'll shorten the screw. I'll shorten this so it's inset quite a bit. It's not going to stick up. All the screws are going to be sunken in. It's going to be perfect. I mean, you guys know me. You watch my videos. I strive for perfection as best as I can do it with my limited resources. But I need a spacer back here. I can't even play with it properly. Okay, hold on. Alright, stole the spacer from this guy. Remember how I was doing with the file and tweaking the stop pin grooves. And noticing in the closed position, as well as the actual detent ball, it's got a bit of a rough time getting into the stop pin. So I'll have to tweak that in the design, because now I've got two things creating a detent, both the ball and the stop pin. And I don't want to confuse everything and having two, so I want the ball to do all the work. And I think at least half of the detent force is coming from the that friction, so I don't like that. The action is a little weak. I would prefer, this is a very light pressure, I would prefer for that to flick all the way out, but the harder the detent is, the faster it's gonna flick out. This is me without any wrist action, just with finger action, trying to get it all the way out. Can't quite do it. There you can. Yeah, if I go straight back, it kind of works. But so I just need a stronger detent. I need to fix the tolerance issue in the stop pins, and maybe tweak the. I bet you if I put a countersink on the detent hole, it'll work better. And obviously, lock bar needs to be cut back more, quite a bit more. If I give it a good hard one, I do get some the tiniest little bit of lock bar engagement. But that's okay, I just got to cut it back a little bit. But it is locked up. Not really any side-to-side play, a little bit, but it's not tightened or adjusted properly. And it is smooth. That is so much better than the button lock, because the drag of this tiny little detent ball versus the drag of, you know, one of these big surfaces on the thingy. And there's no lube, no grease, no nothing. this is so cool. I feel like I'm rambling a lot in this video. Maybe it's because I'm trying to fill it with something and I don't have much else to show. Flipper lever, it's a good size, I guess. I'll leave it there for now. Yeah, I need more detent. Then it'll flip insane. Cool. Well, I got so much other work to do, guys. I got handle orders like so backed up. I got a few big things I'm working on. Big orders. Give you some teasers here. Mini A100 dragon scales. I even put a chamfered thumb groove in there and a left-handed thumb groove and a radius on the front edge. These are going to be awesome. And I got a new knife in the mail today. Emerson CQC7 waved. Titanium? Okay, does that not look like a completely different knife now? Yeah, anyway, that is another video. Here's the same handle stonewashed. They will probably all be stonewashed. So as I said, that's another video. But yeah, I'm probably gonna... That's about it for Knifemaking Tuesday. Don't have a lot of time. But I learned a lot making this test blade. Maybe I'll make another one off video. But this knife is really coming along. Super happy with it. This pattern is epic. Okay, that's it, guys. Way too long. Too much rambling. Not enough cool stuff. So next week, well, once I figure out my test blade and make it perfect, a real blade's gonna happen, and then that's it. Oh, and then the standoffs and stuff. So anyway, thanks for watching, guys. Okay, I couldn't help myself and I can't stay away. So I, the little hole, that's the 16th inch hole we drilled into the blade, I put a tiny little chamfer on it by hand with a bigger drill bit, just me going like this for about 4 turns. And that just put a little bit of a V going into the hole so that the detent clicks in there. And I took the file and I reworked the grooves where the stop pin goes front and back so that they don't drag at all. And now, so the detent I'm feeling, is completely due to the ball and the tension of the thingy and everything. And it's, yeah, it's perfect. If you're a little weak about it, you know, it's not super, the detent could be a little bit harder, so I'll have to tweak that, but it's awesome. Yeah, detent could probably be about twice as hard. By saying hard, I'm saying how hard it is to move this lever. And how would I do that? I think I would just move the hole a little bit over. Well, I'm back. I still can't stay away. So I made a second test blade. Here's the first one. Here's the second one. Key things that I did differently. I readjusted this, the lock face a few thou different so I can get better lock engagement. I increased the, see, this is where the stop pin goes, the angle going into it and the angle going out so that it doesn't bind up anymore. And I created a nifty little groove that basically goes at an angle down. I'm calling that my what's it called? Detent easy groove. I don't know, something like that. Easy groove. And so that's why that way when you close the blade just a little bit from the open position, a little bit closed, the detent will slide up here nice and smooth. And I changed the detent hole just a little bit, like, what was it, 0.2 degree over, to hopefully get a little bit better closed detent. So let's jump into fast forward and assemble this bad boy. Oh, and the other thing I did was I polished the surface a little bit. Some sandpaper, 200, 400, and then buff with the Scotch-Brite wheel. Because this steel is terrible, it's pitted and stuff. So that'll, since the ball detent drags against here, that'll, you know, make it smoother. Okay, good and bad. Detent feels good. New detent location, I like it, but it's tight for some reason. And my detent ball easy groove is good and bad. And it still doesn't lock up a bunch. I did carbonize the face of the lock bar, so I wonder if that added a lot of thickness. And it doesn't quite reach in there and lock up enough. So, pluses and minuses. Got to keep dinking around with it, as always.